So now we've reached a point where we know how to do two different types of regression. We learned how to do linear regression in chapters 1 and 2, and in chapter 4 we learned how to do exponential regression. And that was the same regression that's used in chapter 5. That's why you don't really need videos for chapter 5. Chapter 6 doesn't really have a lot of regression, but nor does chapter 5, but I wanted to kind of show you something that shows up in a couple of the chapters. It shows up in chapter 5 and it shows up in chapter 7, I believe. Right here is chapter 7. Hold on, let me find it in chapter 5. There it is. This is a question, I believe, in, well, I don't really know what section this is. There it is, 5.4. Okay, so it asks you this question in 5.4. It says, here's the percentage of U.S. households that have DVRs, i.e. digital video recorders like TiVo, and then it asks you to use your graphing calculator to draw a scatter diagram. Is it better to do a linear or an exponential function to model this data with a linear and exponential? And then in chapter 7 you run into the same issue. Here's some data, and it wants to know should you do this with linear, exponential, or quadratic data, model for this data. Explain. So let's look at these both separately. I'm going to start with the one from chapter 5, if I could get it in here. Nope, that's chapter 7. Come here, chapter 5. There you are. I'm going to move you over. There we go. I just need to see the data. Alright, so stat, edit. Let's clear these out. Clear. Actually, I don't even need to clear because this is so basic. 1, 2, 3, 4, 5. 1, 2. I'm going to pause. I'm going to be right back with all the data typed in. Alright, I just did a whole bunch of stuff. I know you couldn't see it. I put the chapter 5 data in L1 and L2, and then the chapter 7 data about OxyContin and the prescriptions for OxyContin, which I believe comes from a problem from section 7.2. Yes, it does, 7.2. And again, those notes are available on my website. So let's take a look at these. I'm going to clear this. Let's look at the scatter plots, shall we? So I'm going to go to StatPlot, and I'm going to adjust plot 2. I want plot 2 to be L3, which is where the data is for that, and then L4, that's where the y variables are. So, excuse me, the x list was in L3, the y list was in L4. I really only want one at a time, so I'm going to turn y, go to y equals. I'm going to go up and turn plot 1 on, and I'm going to clear out these other equations. Clear, clear. Alright, so I'm only going to do the chapter 5 problem. You only want to do one problem at a time. So I'm going to do zoom 9, right? Zoom 9. And I can see this data. See it? Like that. So it asks you the question. Oops, that's chapter 7. Excuse me. Chapter 5. Use a graphic calculator. Would it be better to have done a linear or an exponential model? Now when you look at it, you're thinking, it's kind of linear. And it is a little bit, although there is a bit of a curve down here. So to be honest with you, the answer for this one is exponential. And then the question becomes why. So one thing you could see is the scatter plot has a slight curve, and it does. But the other interesting component of this is that the x-intercept. So remember what an exponential curve does. An exponential curve kind of gets lower and lower and lower, but it never crosses the x-axis. If you go back in time before 2001, you can get very, very, very small amounts of DVRs, but you wouldn't want negative amounts. And that's what a line would do. A line would cross over, right, and go negative. You can't have negative amounts of DVRs. So in that case, the exponential is a better choice. So its scatter plot has a slight curve and no negative DVRs before 2001. Now if we go look at the other scatter plot, let me turn off plot 1 and turn on plot 2 and do zoom 9 again. You can see that these points go up and then go down. See them like that? That's obviously quadratic, right? A parabola shape, because parabolas go up and then down. Okay? Sometimes you honestly are just making a guess, like I think exponential is better because blah. So, and you just have to make a substantiated reason for why that is. The no negative thing is kind of a big thing with exponentials, because no negative means that back in time it never crosses the x-axis, which is practical for a lot of real life problems. Alright, that's all there is for that. See you here next time for more regression.